Welcome back, guys, to the second part of our Owen Guns tour. For those of you who haven't seen the first one, where Jason takes us for a walkthrough of their museum and store, I'll have a link at the end and also down below in the description, so be sure to check that out. What we're going to be doing for you today is we have been able to secure a sneak peek for behind the scenes, and Jason's going to take us for a tour of the facility of where they make their Genesis firearms, which is so exciting. I literally couldn't sleep last night waiting for this to happen. So Jason.
All right, thank you for the opportunity.
Now at this point I'm just going to say I'm sorry for the audio quality, but we are doing a factory tour, so we have factory noises, so bear with us as we go through.
Most of this stuff will be normal everyday machinery that most folk will be used to. For example, we need to buy volumes of steel to make sure we get good quality stuff, make sure we've got enough of it on hand so that we don't get caught out halfway through. So it's just a standard steel. Just behind that is a booth we've made for our Cerakoting, because we Cerakote in-house.
Right.
We do as much as we can possibly in-house. Cerakoting is one of the last parts of the job, but because of the way it works, just happens to be first through the door. Bead blasting or soda blasting, because the parts need to be polished up. Conventional, just normal bandsaw like everyone's got at home for cutting the steel to length. Ours is just bigger for cutting the longer sizes, but the same style of thing as a lot of people have at home. One of the most important tools any worker will be familiar with is the tool for hiding all the lies. No matter how much gear you've got, a good linisher is always important to everyone. That's one of the test tubes where we test fire all our Genesis rifles. Every Genesis rifle that we make here is tested to make sure it feeds, fires, extracts and ejects.
Wow.
We do not have a shooting range for accuracy, but we do make sure that they all go bang. This is one of the CNC machines. It's not part of the Genesis manufacturing part. It's for making projectiles and jags.
Right, okay.
Projectiles were hard to get at one stage, so we started making homogeneous or monolithic or solid copper projectiles. That machine is one of the machines that makes it.
Wow, okay.
These are two heat treating ovens. Important parts of the firearm need to be heat treated to different temperatures for different parts. So these ovens are used for the hardening of that. This is the modern workshop. This is 3D printing. We use 3D printing for proof testing. When we come up with a concept, we will print parts first to make sure they'll work before we go and do the codes and manufacture them in the CNC machinery. Certain parts of our firearm are actually 3D printed. Might be magazine parts or things like that, but certain parts are 3D printed. So we laser engrave the serial number, the caliber and all that. That's what we're doing now, is laser engraving what will end up being a receiver on one of our Genesis rifles. Behind you is one of the CNC machines. This is one of the receivers that gets made on that machine. That's where your cocking handle will go. That's your magazine port. That's your ejection port. That is where your scope rail will be on top. So, cocking handle, guide rod to stop the bolt from rotating underneath is that one. Cocking handle, magazine well, trigger, ejection port. That flat section there is where we will engrave our name, our serial number, our caliber and all that sort of important stuff.
That's what we call a canned cycle. That's in a separate part of the computer. When we do a program it'll read that can cycle, and then we'll do what the can cycle tells it to do. But every one of these digits is an instruction for it to make a particular move at a particular time.
Right, okay.
And you know, we've got a readout up here of the RPM. We can tell how far that tool that's in use now has got to go on that movement, where it's going to, where it's come from, the absolute position relative to the machine. Tells us how many hours it's run, how many parts it's made.
Incredible, isn't it?
Yep. If I want to have a look at what it's actually doing when there's a real lot of coolant about, go into there and it actually gives me the movement of the tool as it's moving. So that's the tool going along the profile.
So that's actually happening right now?
Right now. So it's tracing it out into there. The red lines are rapids. The rapid means that it's finished doing what it's doing, what it's there. Changes tools.
Yep.
Right, it'll go in, it's tapping a hole in now, it's put a double coolant on it.
Yep.
It goes in, it gets to about there, and it'll stop and turn around and come back. This will go in reverse. It's coming back now. So it's being a thread, it's got to feed back, it can't rapid back, because if it rapids back, it pulls the thread out.
Right.
So it's a different, it's a special cycle we use for threading.
Yeah.
And then just grab it, it's there in the bottom somewhere.
So that started life like that?
Yeah.
Way, no way.
Oh, that? So that started life. And then in there, so it's done all this etching and everything?
Yep.
And that was the threading that you were saying, that it has to do it a certain way?
You hold that in your hand and I'll just run quickly through it. I'll just measure that to make sure that the machine knows where the end of the part is. Alright, so I'll just close this. There we go. It's feeding out to the outside of the diameter, then it goes back, it'll whiz around to change tools. Then it comes back, and that's where it's doing the diamond pattern on the outside, it's knurling it. Yep. So we do that first so that it doesn't crush it when it's doing it, because it doesn't cut it, it actually like forges it. It displaces the metal to a flat surface to a...
And that's solid while it's doing that etching?
Yeah, it's just doing, it'll do the hole now. It's doing the 8mm hole now, which is that one there, but it's doing it from there.
Yeah,
so it's
right.
drilling right through there. And then there's a little...
it drills from that side out.
If you have a look in there, you can see there's a little tiny boring bar. It's like, looks like that.
So what's that called?
That's the boring bar. That's the end of it there.
And is that what etches that out?
Yeah, that comes in here. It starts down here and goes along and out, in and out, in and out while this is rotating, and just bores it out from 8mm out to 15.87, and then that gets it ready for the thread.
And what's the size of the like what's that thickness when it's done?
Less than a millimetre.
That's amazing.
Oh, we can go a lot finer than that. You know, it does the last profile.
Yeah.
It does the chamfer. It does that overcut there, so the thread doesn't have to start right at the end. It can start a little way in, so it's easier to start. And then it cuts the thread diameter, and at the back of the thread, it cuts this diameter again.
Yeah.
So that the thread doesn't butt up against the back shoulder. So it's just got clearance on the back, so that when you screw it on, it screws right up to the shoulder.
Like a glove. How cool is that? So that's literally just come out of that machine. And that's perfect. That's like butter.
That's what you're taking that much.
You've blown my brain. This is amazing.
It's quite simple, really. This is the hard bit. This here, I could have done that 30 years ago, because I've been doing this for a very while.
Yeah.
But instead of taking me 3 minutes, it would have taken me probably an hour.
Yeah, okay.
So
that's the benefit of
I get
these.
6 or 8 of these done in a day if I was doing them manually. And everyone's the same, but we do one and then we check it.
Yeah.
And then we do 3 or 4, then we check the last one again.
Yeah.
That's done another one now. You down there somewhere?
I feel like a kid in a candy store.
Yeah, it's pretty cool. And this will just screw onto there. Same as the last one. Neat. And all we're left with is a tiny tag on there, which I just get a pair of pliers and it just breaks off. And they look even better when they're on a small barrel. This is a sports barrel.
Right.
When they're on one that's meant for,
Yeah.
it's a nil transition. There's no step in it. There's a batch of bulk carriers that I've just done. Still got the burrs on them. I haven't even taken those off yet. So that's our new bulk carrier, the one that we've redesigned.
Yeah, okay.
We've got one more design feature that's changing again.
Yep.
I'm not going to tell you what that is.
Nope.
Yeah, so that's the inside of it. That's the working part of the whole thing. The firing pin goes inside, the striker goes in there. There's a spring cap that goes on the end with the spring behind the striker. The striker runs in that groove.
Right.
And the bolt head, which is the bolt head goes on in there like that. In that hole there's a cam pin.
Yep.
And because the cam pin's on an angle, as this moves, this comes out. See how when that hole lines up there,
Yeah.
this is out.
Yep.
When this moves in, it moves that in, which pulls it to the back of the barrel and away from the back of the barrel.
Right, okay.
So it actually makes it go in, and when it gets in, the spring and the momentum forces it to do that, which actually loads it, gets it ready to fire.
So these have to be ridiculously precise.
Smack on.
You can't muck around with
No.
that.
Same with all this. All this has got to be smack on.
Yep.
The case holder's got to be perfect. The firing pin hole's got to be perfect.
Yep.
Just about everything's got to be perfect.
So these are all machined here as well?
Nothing gets machined anywhere else. Ron's got a thing where he wants to make everything in Gimpy.
Yep.
And we're all proud of the fact that we make everything. The only thing we don't make
Yep.
is the springs.
Yep.
But these are everything. Everything, absolutely. Even the plastic. We make the plastic.
The bolt head is one of the things that is heat treated. We saw
These
the
are heat
treating
treated.
oven.
Oh, yep. We were just having a look at that.
Makes them hard, brings them up from 32 Rockwell average, which is high tensile.
Yeah.
Brings them up to 62 Rockwell,
Right.
which is equivalent to the hardness of a roller bearing.
This is the machine that we use to guarantee that we're getting that. That is our hardness tester. So rather than thinking, yeah, we've cooked it at a certain temperature for a certain amount of time, she should be sweet, mate, we actually have scientific means of testing to make sure, because different parts may need different hardening numbers. So we have machinery to make sure that A is what A should be, B is what B should be.
Even though the little furnace is computer operated,
Yeah.
and it's got a memory,
Yeah.
so you don't have to worry about inputting the data all the time. If the part's a different thickness or a different wall section,
Yeah.
it needs less heat,
Yeah,
and
okay.
then we just use that just to check it,
Yeah.
just to make sure. Just about everything's hardened. The aluminium isn't hardened. They've got no need to harden these because there's no parts wearing on that too much.
Yep.
They taught me how to make a barrel, so I've been making barrels, and now they tell me they've got the best barrels in the world. So, but it's the equipment that we use and the way that we go about it, and because I'm an engineer, not a gunsmith, I've got different styles of doing things to what these guys are used to, which is an advantage.
So you're running the numbers in your head to
All
make
the time.
sure that the thing is
All the
doing...
time.
Yeah.
All the time. My head's full of numbers.
And that's your superpower.
Yeah, I'd call it a superpower, wouldn't you?
Yeah, he's only 20 years old. It's just all the numbers that made him look that way.
This is only 20. This one's making... This is a drive dog for the cocking handle.
Yep.
So I make that, believe it or not, in the lathe. Which
Right.
is, yeah, which is usually only meant for making round parts.
So you make that in a lathe?
In here, now. Doing it.
That's it.
Yeah.
Because this is actually high tensile steel.
Yeah, okay.
You can hardly hear it cutting, or I'm deaf as a post, so I definitely can't hear it. See, when I machine it, it starts off as a piece of round bar,
Yep.
and I use the milling cutters to machine all this. The tiny little cutter cuts that thread, it doesn't tap it. It actually got a cutter that goes down inside it and does what we call an interpolation while it's spinning.
Right.
While it's spinning on its own axis, it's also spinning on the axis of the machine. Right, so in other words,
Yeah, thank you.
it spins like that,
Yeah.
but at the same time as it's doing that, it's doing that.
Oh,
Right, so it goes
Yeah.
in, it's a smaller cutter
Yep.
than what the hole is. It goes in, starts spinning, does that, and as it's doing that, it comes out and cuts the thread.
Gotcha.
Because small taps break.
Yeah.
And when a tap breaks in that, the part's bugged. You just throw it away because it's very, very hard to get a broken tap out. So yeah,
That
that's
makes sense why you would do it in something like that for that precision.
the diameter we start with.
Yep.
And there's the part. So all I do is break that little end off, and all I'm finished with is the main part. Then I put in the rumbler and deburr it and get it nice and clean. And
So how many of these tools
24.
are you using?
most of them,
Wow.
yeah, and that's what takes the time. Like CNC machines are really good, but you've got to have the quantity to be able to justify using them. This took me almost a day to set up because we haven't made them in here before.
Yep.
I had to work out how we're going to make them, then we had to write the program to make them. So the process is that we draw the part in a 3D image.
Yep.
Then we convert that 3D image into a set of numbers. And when we convert it into a set of numbers in the process, we tell it which tools to do each part of the job.
Yep.
So all that comes to us in numbers.
Yep.
And then we transfer the program to this.
Yep.
And then we've got to go through and read the program and work out where the tools are, where the tool changes are, and put the tools that'll be
In
specified.
the right order.
That's the little cutter, look.
Yeah, okay.
It does that.
Jump in for the cutter.
That one there.
So that's the one that does that.
That's the one that does the thread. Now these are all milling cutters. They're normally on milling machines.
Right.
There's a couple of turning tools on there because there's a couple of turning operations I do before we actually get down to the milling part,
Yep.
which is just basically get rid of the stock off the outside of it. I turn it down from there down to about there,
Yep.
just so the milling cutters aren't working as hard.
Just to get it to a point.
Yeah, where we can work on it.
And you do all of the programming?
Caleb does most of the programming. I program out the machine.
Yep.
He programs the computer.
Yep.
But I just get Caleb to do it. He's smarter than me.
So you're the brains of the machine.
Yep.
Machine's the brains of me.
Yeah.
Without you though, this wouldn't happen.
That's part of the ejection system. So that fits on the bolt carrier, and it's activated by hitting a shoulder at the back of the bolt carrier, which ejects the cell out.
Yeah, okay.
Simple.
And that's made in there?
Yeah, we make that in there.
And that's a hardened piece?
Yep. Yeah, it's got a contact on it, so whenever they've got contact against another piece of metal, direct contact,
Yep.
we harden it.
Yeah, okay. I just can't get over the actual precision. So this is a bigger machine?
Yeah, this is a milling machine that only does basically flat parts.
Right.
The machine will use these cutters to cut the shape that we want. Yeah, it can do things like that, or maybe that group, even though I do all this in the lathe,
Yeah, okay.
because it's one setup,
Yep.
and when I do it in one setup, everything that's relative is in the right position.
Yep.
Whereas if you do it in a machine like this and you just want to do that flat after you've made the rest of it, it's really hard to line it up because it's round and get it in the right spot, whereas the machine does that for me.
So the lathe will move that around. And
I tell the machine how many degrees I want it to move before it cuts this. And then I tell it to move another set of degrees before it cuts that.
and then it puts the holes and stuff in it.
Puts the holes in and drills and that comes out finished. The only bit that doesn't have is that, I'll make that separately. Yeah, we just do some machining like that on both ends actually. Just so we can, when we clamp the plastic on it, or when we clamp the magazine holder to it, it grabs by that and grabs by that and you can't pull it out.
Yeah, okay, did you... So that's going to... So the plastic goes that
Yep.
side?
Yep,
And they're designed to...
fit inside the plastic.
And so the plastic is also created so that it's got those...
Yep, yep. There's one there. See that hole there? That there will fit in there. And it can't come out. You try and pull that out. So you can't.
That ain't coming out.
So, and there's two of them, one on the top and one on the bottom.
And that's made here as well.
Yep. We've redesigned that. We've made it a bit lighter, made it a bit flashier, got rid of the dimples off the outside of it.
So innovating all the time.
Don't stop.
Yeah.
We do not, Ron doesn't let us stop.
So some of these things, like you're saying, you're taking the dimples off and that, is some of that customer feedback as well?
Yeah, it looks shit. Looks like.
So you've actually, so the customers have given you feedback and you've gone, oh, okay, well, let's
Yeah.
think about that and let's
It's
do
exactly
it
what we've
differently.
done. That was my idea originally, and I'll own up to it. But like everything, it's evolved.
That's incredible. So, and I think that, and I get a little bit, and we've had one of these moments in the museum, but I get really passionate about Aussies innovating. And the fact that you guys are on the phone to each other, and Ron's here Monday mornings going on,
Yeah.
and then there's something actually tangible that goes out to customers
Yeah.
from Australian brains, that just is what ignites me.
We don't get any feedback from the customers as such saying that they're glad that we do that. We just do it so we've got a good product.
Oh, wow.
We're just doing some prototyping work on a new format for the rifle, and it'll just make it better for the market.
Yeah.
Yeah. Yeah, the market will fall over backwards for it. Yeah.
You heard it here first, guys. You're going to fall over backwards for what they're cooking.
What's coming out, we will. Yeah. We made this. I've just fitted all the new guide rails to it. We put the drill in here.
So that's the drill.
That's the drill, and it's got a hole up the centre of it. Doesn't even look like a drill, does it? Get a close up at the end of that, it'll blow you away. And up the centre of it is a hole. You can see the exit for the hole just there. If you have a look at the end of it,
Yep.
that goes right through. So the coolant goes through the drill, it comes in here, it goes through the drill, and the coolant comes out exactly where the drill is cutting. So it keeps the heat out of it, and it's under really high pressure, like it's under nearly 1600 psi.
Yeah.
So it's actually pushing all of the shavings back out this groove. So when you're finished, you've got a little pile of shavings there like that at the end of the drill, because it pulled them all out of the drill. Because if it gets hot, it can bend it. If it gets hot, it can score it,
Yep.
right? And it can wear the end out as well.
So how did you get a tool like that?
We designed it and got it made. This particular
So it wasn't a
one,
Bunnings job then, mate?
that's, I think the other thing is, you might ask me how we keep that straight. We don't, it just keeps itself straight, believe it or not.
And because of the spinning maybe, or...
This doesn't spin.
Oh,
This doesn't spin at all. The bit that spins is in there. This is a barrel. The barrel doesn't normally go in there. I've got it in there at the moment because I've been using it for an alignment tool to line this up with this in 2 axes so that I know it's perfectly straight, so that when it drills, it'll drill straight through, because if these aren't in line, it'll drill a crooked hole.
Yeah, okay.
Like it'll come out one side at the end about 3 or 4 mil, and we've been getting them to within 2,000. Out of 16 inches away, it runs out 2,000. So the barrel goes in there. I've got some supports here for the barrel to support it here, and the drill just goes in there like that. And I've made up all the electrics so that we've got the electrics driving, and it's all variable speed. I've got potentiometers on here that vary the speed of the truck, they vary the speed of the feed rate, so that I can get the exact right feed rate to the RPM, so that it's not spewing off and it's not rubbing. And
then you note that down, and that's your true point every single time then, yeah?
Yep, and then we measure it and make sure that it's in the right spot, and then we rifle it. Made our own rifling buttons to rifle them.
Of course you did, why wouldn't you?
Well, we don't buy shit. So I haven't machined the outside of it yet. I've just machined it there so I can hold it.
Yep.
And there so the steady can hold it.
Yep.
And that's all I've done.
Yeah.
So I've still got a fair bit of work to do to that, but that'll turn into a really lightweight barrel.
Yep. So you'll then make the outside diameter meet the inside
True to
diameter.
that.
So when they used to make barrels, or all barrels are made in a larger diameter like this for manufacturing purposes. When you do this, you'll then turn it down to a sporting weight barrel. That will then true up the center bore to the outside of your barrel. When we talk about our barrels get hot and they shoot off to the side, that's because in some barrels it'll be thinner on one side than it is on the other, because the hole wasn't true.
Right.
So then your barrel would throw shots off to the side. In the good old days. Now that manufacturing is getting better and better and better, we are seeing our target rifles shoot better than they used to when the barrel's hot. It's because of the improvement in technologies like that.
Yeah.
So when you turn this down to a sporting weight barrel, it will fix that up. If you were to cut the old-fashioned barrels, like if you get an old 303 barrel or an old 22 barrel and you cut it down the center, you will see thin parts and thick parts all over the place.
Because they didn't have the technology that we have now.
It's almost impossible to drill a hole in a long, if you get yourself a 26-inch barrel, nobody in their right mind is able to drill that hole perfectly down the center of what you finish with.
Yeah.
That's the fixture that I made up just to go into there. So the barrel rests against those rollers, and those rollers spin. They're hard against the barrel.
Yeah.
2 on this side and 2 on this side, and they just centralise it to stop the end of the barrel wobbling and fluttering.
Yep.
So that just keeps it all steady.
And that's the reason they're called a rifle. That twist that you can see in the barrel is rifling. It imparts gyroscopic stabilisation to your projectile, just like a kid's spinning top. That's what stabilises your projectile.
And it's not cut, it's formed. So there's no metal removed in that process at all.
Right, so we've seen all of the really cool stuff. We've seen the CNC machine, we've seen the rifling, we've seen all of the magic that happens in the assembly space. Now we get to come to the magic room where all of those cool bits and pieces become a real thing. So
yes, they're manufactured downstairs, but the firearm actually gets put together, assembled, quality control tested here. Then they go back downstairs for test firing and things like that. But this room here, henceforth, it's kept with just the tools, nothing else that we need. This is where the boys, men, staff get to put them all together and do a quality control. Yep, that doesn't feel quite right. Take it to one of the other guys to find out what's not right. Go from there. Yes. So this is a very important room. As you can see, they've got them in varying degrees of, this is the bulk carrier group we had a look at downstairs. This one is empty. This one is at its next step. It's got the firing pin, it's got the firing pin spring, and it's got the plug to hold it in, but it hasn't progressed past that yet. So yes, the firearms are made downstairs, or the parts are made downstairs, but the firearm itself gets made here. Yeah.
So roughly how many would be getting assembled here a day, a week?
At the heyday, I believe the guys were putting together something like 10 a day.
Excellent.
Now, having said that, they may have gone and made 100 receivers and they may have gone and made 100 bolt carriers, but they would take that time to put them together, make sure it worked, tested, make sure they're in the register and on the paperwork and all that sort of stuff. But yeah, it was about 10 a day.
10 a day, wow.
Yeah.
That's yeah, impressive.
Make sure you brace it with your leg against the leg behind it.
Okay, I should probably remove my phone then.
Push in. Got you by surprise, didn't it?
Let's go. Sick.
Merry Christmas.
Oh, let's go.
It's still warm. Have a sniff. Go on. All right. Good morning, everybody. How are we? Or hello, everybody. What we're going to do today, I'll just see if you can have a look in there or someone prove in there that that chamber's empty for me. Clear. Magazine well. Are we happy the gun's cold?
Yep, she's cold.
Cool. What we're going to do here today is basically disassemble the firearm that you would do to that level for the cleaning of. Okay? So the first thing you always do with a firearm is prove gun's clear. On this rifle, we then bolt forward, decock it. Depress that tab on the back and unwind the buttstock. Insert rude joke here. Be careful because that happens. Pull the cocking handle back, the bolt carrier group comes out. I can then take the bolt carrier group out. You got to be careful because the cam pin can fall out. It's not actually pinned or anything in there. That is how you would clean this firearm from the chamber end, which is the way you should clean firearms when possible. That's what it looks like from the business end when the bolt's together. We talked about the ejector. See, there's your ejector plunger. When that comes back, it hits. So it is a mechanical ejector. If you do not pull the bolt handle back hard enough, you will not eject your cartridge off the bolt face. If you do it the way it's meant to, you will hit the guy next to you in the shooting bay. So to reassemble the firearm, after having cleaned it properly, is simply making sure that your cam pin doesn't fall out. Depress trigger. Action return spring. Depress that button. Rotate down to the correct size. As simple as all that. Thank you.
Let it fall
Now
out.
pull it all the way back and let it. Yeah. So yes, now that you're in position.
That's it.
Yeah. Now we've also built it with that higher piece because all these AR platforms, you need to have such high rings it's not funny, whereas we've built that. Cool.
We've got to get one of those.
We've got to get one of them.
Now I'm going to grab that.
I have a question. So are these each individually numbered?
Yeah, serial numbers and the bolts numbered with the serial number. Yeah.
That's really cool.
Yeah.
We're keeping you up because
Okay. Well,
And
sure.
how much did that one weigh?
standing
I think this is
falling
3.6
asleep.
or 3.4
Medication's
Wow.
kilograms. Well, the others are another kilogram heavier. You know, like
Snag it.
I think the 4.1's the sporting weight, and about 4.6 kilograms is the one with the heavy barrel.
Yep.
Yeah.
Nice.
Okay.
Just check up the NAS clear for me.
Yep, clear. Clear.
Feel the weight of that compared to, see, that is noticeably lighter again than the one we had. So pull your pump back a little bit. No, just pull your pump back. Yeah. See? So that's how you actuate it now, as opposed to having to use your bolt handle.
Yeah.
You haven't modified your gun because it's still a bolt. You would undo those two screws, take that off, slide that off the front. Exactly. So any of the ones that we've already got, you can go and buy that. So it's an add-on. It's not a modification, it's an add-on.
Yeah.
But see how light that one is now?
Once you're done, I want to.
Keep the barrel on that way.
Then who's going to hold the camera for that?
Oh, that's really cool. Oh wow. You just bring it back and then it goes.
That's pretty well as light as his Ruger.
Yeah, this is good. It's like the pump makes it easy to hold, I think.
And that, without having scales, would be the same weight as that M4. And yet we've still got all that steel for strength. We've still got all that there for reinforcing purposes.
Yeah.
That particular one's in 243 because that was the barrel we had at the time. But we can do that to any of the cartridge caliber specifications that we have.
Yeah. And that's changed all the time too.
Yeah. As Trevor was saying downstairs before, he's done away with the bubble domes. We've removed a lot of that because that was some of the feedback we're getting from customers. When I'm sitting at a bench with it, I have to lift my gun up to get the magazine in, whereas now I can have that lower. Just little things like that. Once again, if enough people say the same sort of thing, we'll look hard at it.
They're the guns. You don't want me. They're the guns. Guns are more important. Yeah.
These are all the Genesis.
Well, they're 223 ones.
Yeah.
We do 223, 243, 6.5 Creedmoor, 300 Blackout,
Yeah.
and 308.
What's your favourite one?
And we've got 22 in development, and we've got 300 Norma Magnum in the works as well. And we've got a couple of 6.8 SIGs.
Nice.
But the ammo, we have to make our own ammo for that.
Yeah.
Hey guys, thanks very much for staying to the end. Really appreciate it. We've definitely had an education going through the making of a firearm. What was your takeaway from getting a factory tour, mate?
It's too complicated.
There's lots, isn't there? Yeah. My takeaway is their attention to detail and how much they rely on customers' feedback and actually apply it. So definitely an amazing piece of kit that they are producing here in Gympie. And again, as you know from watching our past videos, we are well and truly 100% supporters of Australian made and owned, and you don't get more Aussie made than here in Gympie. So if you're in the area, come down, check Owen Guns out. They've got the museum out the back. If you haven't seen our museum video, make sure you check that out as well, because Jason did a great job taking us through the museum. Yeah, can't speak highly enough of Owen's Guns. They've got firearms, they've got hunting gear, they've got all sorts of everything here, and they're just ready and willing and able to share their knowledge and take everyone through. And yeah, definitely come down, check Owen Guns out, and make it a must-do on your list when you're in Gympie. Thanks everyone for watching. Remember to like and subscribe, and we'll see you on the next one.
Bye.